In practice 1, we will be going through how to run a two-way mixed ANOVA. So here we've got a description of the data that are presented in the Excel spreadsheet for Activity 9. A researcher was interested in seeing if the primary mode of cardio exercise affects the VO2 max measured on a similar apparatus. 60 participants were equally divided into 3 different training programs for 1 month. Frequency and intensity of exercise was kept consistent among participants. VO2 max was measured in milliliters of oxygen per kilogram per minute for each subject, using protocols on 3 different pieces of equipment: treadmill, rowing machine, and a cycle ergometer. So from the description of the data, we can see that we've got people who are equally divided into 3 different cardio training programs. So the type of training program or exercise would be our between subject independent variable. And then it says here that we measured VO2 max using 3 different pieces of equipment on each person. So this would be our within subject independent variable. Each of our variables has 3 levels. So 3 different training cardio programs and then 3 different protocols or 3 different pieces of equipment. For this particular practice set, we're going to run a two-way mixed ANOVA and SPSS. I'll take you through the output and how to interpret the results. And then we will create a bar graph that represents the differences between the means of the VO2 max protocols within each mode of exercise. Lastly, we will identify and interpret the effect size for the significant main and interaction effects in the ANOVA. So this part is more or less going to go with the interpretation of the results from the output. If you have any questions on how to run the test, or if the video is not sufficient, or you just want to go back and reference the steps to how to run a two-way mixed ANOVA, feel free to look at the Module 9 Part 2 PowerPoint for picture guides and another example. When we look at our data, we can see that our mode of exercise or our training program is listed in this first row. So we have a running program, a cycling program, and a rowing program. And then we have similar pieces of equipment that kind of match the running, rowing, and cycling exercises. So these would represent the protocols, and then the values that are actually presented in the data are going to be representing the VO2 max values that we collected from each of these protocols. So each row in this set of data represents one subject. Each row in this set of data represents a different set of subjects, and each row in this data set represents another set of subjects. When we organize our data in SPSS, one of our columns should be kind of given to the between subject independent variable, and the other column should represent the measurements that were taken for the levels of the within subject variable. So given that we have one between subject variable, that's one column, and we've got 3 levels of the within subject variable, that's an additional 3 columns, so we should have 4 columns total that we are transferring into SPSS. We can start by reorganizing the data over here on the right. So I'm going to do it down here so I don't get bothered by, actually, no, I'll do it up here. That's fine. Never mind. Okay, so we need a legend that lets us know which data labels are representing which between subject level. So we can have 1, 2, and 3, make it pretty simple. 1 will represent the running group. 2 will represent, I'll move my mouse, the cycling group, and 3 will represent the rowing group. So these are the modes of exercise, and I can put that up here. Mode of exercise. Okay. We would then have a column representing the mode of exercise or the training program that they're in. So my first set of data I'll put in for my running people, and they will have 3 measurements for VO2 max, one using the Bruce treadmill protocol, one using the rowing machine protocol, and then one using the cycle ergometer protocol. So I can go back over to my running data. I'll copy their VO2 values and then copy the value 1 in mode of exercise so that I know all of these people were in the running training program. I can then do the same thing for my cycling group and give them a data label of 2. And then lastly, do the same for my rowing group, and they get a data label of 3. My data are now ready to put into SPSS, so I can copy that information and then paste it into my data view. If I scroll all the way down, I should have 60 subjects because that's what was listed in the description of the data. In variable view, I need to note that my mode of exercise is a nominal variable because that's my between subject variable. And I have values 1 for running, 2 for cycling, and 3 for rowing. My Bruce, rowing, and cycle ergometer, these are the 3 levels of the within subject variable, so each of these should be set to scale since the values in each of those columns are representing the VO2 max values that I measured or that the researcher measured for each protocol for each exercise program. So now our data are set up correctly. We can go to Analyze, General Linear Model, and Repeated Measures. Then we can stick in our within subject factor, which is the protocol, or you can put equipment, either way. There are 3 levels, and then the measure that we have collected is VO2. Click Define, and now we can see that we've got protocol in parentheses, levels 1, 2, and 3, with our VO2 dependent variable listed on the side. So it's up to you how you label 1, 2, and 3. I'm just going to put all of these in as such. So my Bruce protocol is protocol 1, rowing is protocol 2, and my cycle is protocol 3. My mode of exercise is my between subject factor, so I'll stick that in there. I then want to set up my post hoc tests. So I'll stick everything into the display means for and use a Bonferroni adjustment to compare the means. Lastly, I can go to Options, choose Descriptive Statistics and Estimates of Effect Size, as well as the homogeneity test so that my between subject factor can be tested for homogeneity of variance. I'll click Continue, and then we'll click Paste. This will open our syntax window. So now we can see that our post hocs have been set up for our mode of exercise and protocol, and then we need to add in that we want to compare. I'll choose mode of exercise from the drop-down list as my first independent variable. And I'll use, whoops, that went in twice. I'll use a Bonferroni adjustment. Okay. Enter down. and then we'll just copy and paste that line of syntax. And then instead of mode of exercise, we're going to put protocol. So once we have our syntax set up so that we have the pairwise comparisons set to calculate for our interaction effect, we can go to run, all, and then we get an output. So in the output, I'm going to take the notes out. At the top, we can see our within subject factors. So if you forget how you labeled the protocols 1, 2, and 3, this is where you would be able to find it. Okay, so we have treadmill, rowing machine, and cycle ergometer. Our between subject factors, mode of exercise, again, the values associated with each mode of exercise are listed in that table. When you get to Box's test of equality of covariance matrices, just delete that. We don't use that in this class. We also won't be using the multivariate tests, so I'm going to cut those out as well. And then the first test you see in here is Mauchly's test of sphericity. So right away, we can see that we've got a p-value of 0.506 for our within subject independent variable protocol. So this would indicate that the variances of the differences between all three protocols are relatively equal because our p-value is greater than 0.05. So this would indicate that we have met sphericity for protocol. Then I can toggle down to Levine's test because we have to make sure we've got both assumptions met. And on Levine's test, we should have 3 different p-values because we have 3 levels of the within subject variable by which we are comparing the variances of the between subject variable. So this Bruce treadmill line that's associated with this p-value of 0.427 is telling us that there are equal variances between our exercise or between our modes of exercise, between our training programs within the Bruce treadmill measurements. This one would say that we have equal variances between the modes of exercise within the rowing machine measurements. And this one would say that we have equal variances between modes of exercise within our cycle ergometer measurements. So in all 3 cases, we have met our assumption of homogeneity of variance because the p-values are greater than 0.05. We know from Mauchly's test of sphericity that we have assumed sphericity for protocol, so this would indicate that we would read the sphericity assumed p-value for both protocol as well as the interaction effect. So that takes care of our assumptions. Then we can look at our ANOVA table. So I'll start with the test of within subjects effect since it's right here. And we said that sphericity was assumed. So I'll highlight the p-value for protocol, and I'll also highlight the p-value for our interaction effect. Interpretations of each of these, right, both are less than 0.05. So I would report my p-value for protocol, or the main effect of protocol, as p is less than 0.001. And this indicates that there's at least one significant difference between the protocols for the VO2 that's measured. And this would be regardless of the mode of exercise that a person participated in. Since we're in this table already, the interaction effect between protocol and mode of exercise, the p-value is 0.001 or less than 0.001, which is less than 0.05. So we reject the null hypothesis and state that there is a significant interaction effect between protocol and mode of exercise for VO2. The last main effect that we have to check is for the mode of exercise, which is our between subject effect, so we'll find that in the test of between subjects effects table. We can note our p-value also less than 0.001. Oh, whoops, just kidding. Nope, I didn't say that. What? That's for the intercept, which we don't care about. This is what we care about. P-value for mode of exercise. I just got clicker happy. Okay, so our p-value is 0.344. This indicates that we do not have a significant effect of mode of exercise on VO2. Okay, so in this case, because we do not have a significant main effect for mode of exercise, we do not need the pairwise comparisons for mode of exercise. So to remove the temptation from you, just go ahead and if you click on the little yellow box over here in the kind of like the outline of your output, just delete mode of exercise, because no significant main effect means that there should not be any significant pairs in the pairwise comparisons. We do, however, need to check the pairwise comparisons for protocol, as well as both of the interactions for mode of exercise and protocol, because those were significant main effects. So if we check out our protocol pairwise comparisons, we can note that we've got protocol 1 representing our treadmill, or Bruce treadmill, if you want to remember it that way. Protocol 2 was, I think, our rowing machine. And I'm going to double check that because now I forgot. Yes, it is the rowing machine. Okay. You see, sometimes you need assistance. Okay. And then our last one was our cycle ergometer. 2 was rowing. 3 cycle. And 1 is treadmill. Okay. So when we look at the p-values for our pairs, we can note that we have 3 significant pairs. Again, these ones here are repeated, so I'll put them in purple. Okay. So we've got a significant difference between the treadmill and the rowing protocol for VO2, a significant difference between the treadmill and cycle protocol for VO2, and a significant difference between the rowing and cycling protocols for VO2. Another way we could word this is that all pairs or all protocols are significantly different from each other for VO2 or for measured VO2 max, regardless of the mode of exercise that was performed. So that would be our kind of conclusive statement for the significant pairs for our protocol independent variable. For our interaction effect, we can go into our pairwise comparisons, like our first set of pairwise comparisons. And I'm trying to get into this table. There we go. Protocol 1, again, was treadmill. Protocol 2, rowing. And protocol 3 was the cycle ergometer. Okay, so in here we're looking at, are there significant differences in the modes of exercise or between the modes of exercise within a certain protocol? So when we look at our pairs over here, that is a non-significant value. This is a significant value. Okay, so we know that running is significantly different from rowing. When we look at the comparisons between cycling and running and cycling and rowing, we've already repeated 203 or 0.203, so can kind of skip that one. And the differences between cycling and rowing have a p-value of 0.397, which is larger than 0.05, so that would not be a significant difference. So the only significant pair between modes of exercise within the treadmill protocol are between running and rowing. We then can go to the rowing protocol, and we can see that none of the pairs of modes of exercise are significant. And then lastly, we can look at the cycling protocol, and we see a similar instance where none of the pairs are significant. So for this pairwise comparisons table, we would say the significant pairs are between rowing and running for the treadmill protocol. Okay. The last set of pairwise comparisons we look at are for the differences between protocols within each of the modes of exercise. So in here, I'm going to change 1 to the treadmill protocol, 2 to rowing, and 3 to cycle. Do the same over here. Okay. And then we can see in here, we've got a significant difference between treadmill and rowing and treadmill and our cycle protocols, as well as a difference between our rowing and cycling protocols within people who performed the running mode of exercise or the running training program. For our cycling training program group, we've got a significant difference between the treadmill and rowing protocols, and it looks like that's it. So the significant pair for this one would be that there are significant differences between the treadmill and rowing protocols within the cycling training program or cycling mode of exercise. Finally, for our rowing mode of exercise, we have significant differences, it looks like, for all of our pairs. Okay. So one way that we could summarize these findings here, we have all pairs of protocols, or all protocols are significantly different from each other in the running and rowing modes of exercise. And treadmill and rowing protocols are significantly different from each other in the cycling mode of exercise. So that concludes kind of the analysis of our ANOVA. Then we need to look at effect size. So I'll start with our test of within subjects effects, or the protocol independent variable. And in our table, we can see that our effect size, whoops, I meant to do yellow. Our effect size for protocol is 0.625. So this would mean that we have a large effect size for the differences between protocols for VO2 measurements or VO2 max estimates. For our between subject effects variable mode of exercise, our partial Eta-Squared is listed in here. Okay. 0.037 is kind of in between a small and a medium effect size, because it's small is considered around 0.01, medium around 0.06. So I'm going to argue this is kind of closer to a medium effect size, but you could say it's a small to medium effect size for the differences between the modes of exercise. And then our effect sizes for our interactions are going to be found in the univariate and multivariate test tables that are underneath the pairwise comparisons. So pairwise comparisons that look at the differences between the modes of exercise within the protocols, we only had one significant pair in the treadmill group. So in my univariate table, 1 is representing the treadmill group, right? And I have, an effect size of 0.168. So this would be considered a large effect size for the differences between my modes of exercise within the treadmill protocol. The effect sizes for my other bout of pairwise comparisons, we had significant pairs in each of the modes of exercise. Therefore, I would report the effect size for each of the modes of exercise. So I'll highlight those in the table. And we can say all of these are larger than 0.14, so they're all large effect sizes. Okay, so the running, this would be interpreted as there is a large effect size for the differences between protocols for the running mode of exercise. There's a large effect size for the differences between protocols for the cycling mode of exercise, or the cycling training group. And then there's a large effect size for the differences between the protocols for the rowing mode of exercise. That kind of covers everything that we would need to go through in our SPSS output. So I'll minimize all of that stuff. And then the last thing we have to make is a graph. So I'm going to come back over here. And here's what we're going to do. I had specified that I wanted you to make a bar graph that represented the differences between the means of the VO2max protocols within each mode of exercise. So each mode is going to be a series in your legend. Each mode is going to be like a different section of your x-axis, and then each of the protocols is going to be like a series in your legend. So there are multiple ways that we could set this up. We're going to do an averages table first. So I'll just type that there. And we're going to do, let's do our modes of exercise going downwards. So we'll have running, cycling, and rowing. And then across the top will be the protocols that were performed. So Bruce, treadmill, rowing machine, and cycle ergometer. And then in here, I would just be calculating the means for the running group that performed the Bruce treadmill protocol. And I can keep going across. So this is rowing and Bruce. And then for each of these, I can copy them across. That way, if I double click, right, I'm in cycling group who did this cycle protocol. That lines up with where it's supposed to be. I'll make all of these 2 decimal places. And then we'll do a similar table for the standard deviations. And instead of averages, we'll do STDEV. For the same groups. and then I can do the same thing and just copy across. Then I will graph my averages. So I'll go to Insert, Graph. I'll do a bar graph. Okay. A nice chart title might be mean VO2 max for different protocols. Across various modes of exercise. Sure. Okay. My axes titles, our x-axis is going to be the, well, I said within each mode of exercise. So actually, the way that I input this, we need to switch it because I asked you guys to compare the protocols within each mode. And the protocols right now are listed here. I actually want them the other way. So now I'm looking at differences between protocols, which are the bars noted in the series. And then those are within each of the modes of exercise. So my x-axis title should be modes of exercise. And then my y-axis is going to be VO2 max in milliliters of oxygen per kilogram per minute. Okay. We should add error bars on here. So let's go to add chart element. We'll do the treadmill protocol first. So we'll specify that our positive error values, notice I'm in the treadmill grouping. So my standard deviations should be going this direction. Okay. My negative error values go that way. Okay. For my rowing machine protocol, we're going to add some error bars and then specify the error values with the rowing machine column. Oops, there we go. And then lastly, I want to add error bars to, I didn't mean to click standard deviation. Poop. I wanted more options. And we'll set the positive and negative values to the cycle ergometer standard deviations. And then, again, personal preference, I like my y-axis as nice whole numbers, so I'm going to change that. And I think I'm also going to change this to a factor of 20. Honestly, it doesn't really matter, but here we can see now the differences between the means for each protocol within each mode of exercise. Okay, so that would be a nice acceptable graph to submit on your answer sheet.